Hello friends, I am Dr. M. Fatima. Today I am taking introduction of multiplexer. In this, I am going to take 4:1 multiplexer. First of all, what is multiplexer? It is a device which allows the information from several sources to be routed on a single output line or on a common destination. This mux consists of several data input lines, single output line, and data selector inputs. Depending on the select inputs, number of inputs are decided. Like here, 2 raised to m equal to n. M is the number of select lines, n is the number of input lines. So depending on this, if the m is equal to 3, that is select lines. If the select lines are 3, then this will be 2 raised to 3. So this is equal to 8. So n will be equal to 8. That is, n is the 8 data input lines. So 8 data input lines will be connected for 3 input select lines. This is a functional diagram of the multiplexer where it is showing the input, this is select line, and this is output. Output is denoted by Z, inputs are denoted by I0, I1, and so on. Select lines are denoted by S0, S1, S2, S3. So if M equal to, that is select line equal to 3, then 8 inputs can be connected to this multiplexer. So 8 input lines will be routed to the single destination output. This is the functional diagram of 4:1 multiplexer. Here, 2 select lines are connected. If select lines are 2, that is if the value of M is equal to 2, then the number of inputs equal to 2 square, that is 4. So here 4 input lines are connected. This is the single output. These 4 input lines will be going to connect to the this single output. It depends, the connection of these input lines depends on the value of these select lines S0 and S1. So say here, this is the truth table of the 4:1 multiplexer. The value of S0, S1, these are the two in control lines. Depending on the value of these control lines, the input will be connected. Like the input are I0, I1, I2, I3, and like the select lines are S0 and S1. So you can see here S0, S1 are the select lines. So depending on the value, this value, like if it is 0, 0, then I0 will be connected to the output. If 0, 1 are the select line values, then I1 will be routed to the output. If the value of S0 equal to 1 and S1 equal to 0, that is if the select lines are 1, 0, then I2 will be routed to the output. And if the select line S0 equal to 1, S1 equal to 1, that is 1, 1 select line values, then I3 will be routed to the output. So this is the logic diagram of the 4:1 multiplexer. Now how this logic diagram is developed, let us see. So here this is the truth table we have already seen. This is, let this be S0, this is S1, and the Z is the output. Let the value of S0 equal to 0, this is equal to 0, then it is considered that I0 will be connected to the output destination. If it is 0, this is 1, then I1 will be connected to the destination output, that is output. If it is 1, 0, then I2 will be going to connect to the destination. If it is 1, 1, then I3 will be connected to the destination. Now, write the equation for this. For the 0, I can take the complement of this, and for the value of 1, I will take the value as it is. So yeah, you can see this is 0, 0. So I can take S0 dash, S1 dash for the 0, 0 values. So this is S0 dash, S1, and output, what I want, this I0 should be connected to the output. So I'm writing here I0, then plus, write the value of this. This is 0. So this is also equal, this is equal to S0 dash, this is equal to 1. So the value of S1 is taken as it is. So I'm writing here S0 dash S1, and what output I want to connect? I1. So I'm writing here I1, then plus the value of this S0 here is equal to 1. So I'm writing here S0. Now what is the value of S1? This is equal to 0. So I can take S1 dash. So I'm taking here S1 dash, and what output I want to route to the output? This is I2. Last one. This one is the value of S0 and S1 equal to 1. So I can take S0, S1 as it is. So I'm writing here S0, S1. and I3 I want to connect to the output now. So this is the equation of the functional equation of the 4:1 multiplexer. So see, this with the help of this, we can draw the logic diagram here. So I'm drawing here. How many AND gates are required? 1, 2, 3, 4. 4 AND gates are required, and to connect all this, one OR gate is required. So 4 AND gates are required to connect. So see here. So I'm taking here S naught. Let this be the S naught. Taking the complement of this. This is S naught dash. Now take S1. Take the complement of this. So now this is S1 dash. So see, on first AND gate, S naught dash, S1 dash is required and I naught is required to connect. So I'm connecting here, this here and from here. So this is S naught dash, this is S1 dash, and I want to connect input I naught here. So I'm writing here I naught here. So output of this is equal to S naught dash, S1 dash, and I naught. Now similarly connect this one S naught dash, S1 and I1. So S naught dash is already available here. So I'm connecting here S naught dash. Then S1 is required to connect this S1. Now I1 is required to connect. So I'm connecting here I1. Now the output of this AND gate is equal to S naught dash. So this is S naught dash S1 I1. Now next is S naught S1 dash. So here I'm connecting S naught. This is S naught, then S1 dash is required to connect, and last one is I2. Yeah, so the output of this becomes S naught S1 dash I2, and last one is S naught S1 I3. So here this one you can see this is S naught. So let's take it. This is S naught, then S1, and then I3. So see, output of this is S naught, S1, I3. Now, to connect all this, one OR gate is required. To connect all this, I'm drawing one AND gate here. So output is taking from here. So this is Z. So see, this is the logic diagram of the 4:1 multiplexer. Although we can draw the block diagram also. This is the 4:1 where inputs will be 4, I naught, I1. This is I naught, I1, I2, and I3. There will be two select lines, S naught and S1, and output Z. So depending on this, the values of select lines, this will be routed. Like see here, if the value, if see the value of S naught, let be equal to 0, and S1 is also equal to 0, this one. So see, put the value of S naught S1 in this equation, in this whole equation. So see, this is equal to Z equal to S naught dash. So this becomes 1 dot, this S1 is equal to 0, and we have to take here complement. So this is also becomes 1 into I naught plus this is S naught dash is equal to 0. Complement of this is 1. S1 value of S1 is 0 into 1 plus the value of this S naught is 0. The value of S1 is 1. I2 plus value of S naught is 0. S1 is 0 and I3. So you can see this term becomes 0. This term is also 0, this term also becomes 0. The output is only I naught. So you can say by the selection of input select lines, by the selection of these select lines, the I naught can be transmitted by this. So with the help of selection of these select lines, I naught, I1, I2, I3 will be routed to the output. So you can see here what I drawn on the white screen. This S0, S1, two select lines depending on this I0 will be routed I1, I2, and I3. So what I draw on the screen, white screen, this is also available here. This is the logic diagram of 4:1 multiplexer. That is inside of this block, this logic diagram is present. These gates are present. Thank you. This completes this lecture.